Hello, computer science geeks. We're going to do a little lab here today. It's on the comparable interface. And we're going to do it on a class called SortablePoints. So if you're in my class, go to the Student Resources folder under Unit 11. I want you to download the sortablepoint.java file. We're going to work in there. I'm asking you 3 questions, things that you need to do on your own, okay? Because you need to figure it out. And after you do this stuff, then I'm going to work through it with you. We're going to give you all the answers here online. So you need to pause the video and do this first before I give you all the answers. After you figure out these things about the code, you're then going to write a new compare-to interface that's going to sort the points by their quadrant number. And if you feel like it, then you can go on further and you can find out different ways to sort the points. Not only are there different ways to do it in code, but there's just different logical ways how to sort the points. Okay? I've downloaded the sortable point class. We're going to look at it here. First, we're going to review what's inside of it, and then we're going to go ahead and we're going to do the lab right here online in this video. So what you see at the top first is that I import the Java AWT point class. Okay, so this is going to be using this point provided by the Java class libraries. So if you have your own point class, just go ahead and not use that. Make sure we're using the point class here, so we're not going to add any sort of personal point to this at this time. You totally could add your own point class to it, but you might have some accessibility or access issues. So let's just use AWT. Right out of the gate, we see that sortable point extends point. That means we're using inheritance. We're going to extend this point. We're inheriting from point. We're going to get all the functionality for point for free. And then we're going to do even more than what the point class does. We are going to implement this comparable interface, and the syntax that it gives for us is we have to use bracket and then the sortable point, which is our class right here, right inside of there. Okay. In our main, we're creating an array. We have 6 points in an array at various locations in each quadrant and on the axes. So we do a new operator. We create a point, so we have an array of points objects. And then we are going to print out the points, we're going to sort them, and then we're going to print it out again. Okay? This file is as it is up on the share, so nothing has changed. We're going to look here at the constructor. At this constructor, you can see that we have to call the superclass constructor because the superclass constructor doesn't have any default constructor for us. So, or actually it might, but we're going to call it directly. I wonder if I take that out. You can test it out. Then I provided a method, the distance to the origin. So here we just, whenever we ask for it, what we're going to do is we're going to get the x from our point, we're going to square it, we're going to get the y from our point, we're going to square it, and then we're going to take the square root of that, and that's going to be the distance to the origin. Okay. Here are how the quadrants I wanted how them to be done. The zero quadrant, or the quadrant 1, quadrant 2, quadrant 3, quadrant 4. We're going to sort them by these quadrants later on. And if it is on the axes, then it's going to return a value of 0. So you can see here, if x is less than 0, then we're going to be in quadrant 2 or 3. Okay, and if y is greater than 0, then we're going to be in quadrant 1 or 2, but since we've already handled it before, we return 1, otherwise return 4. So this is just, there's lots of different ways to return which quadrant you're in. So here is the first implementation of how we're doing compare to. So this compare to comes from the comparable interface. It takes a sortable point that is the other. And what we're going to do, as you saw in the video before, is we're going to subtract this distance to the origin from the other distance to the origin. But because we need to return -1 or 0 or +1 as an integer, we have to use the math sig num. Okay? So we have to get the sign from our number and then return an integer value. So this does it for us, and then right down here, commented out, is a new implementation of compare to that we're going to do later on. So if I were to run this guy, if I were to run it, what you'll see down here in the console window is it first prints out the points, okay, in the order in which they were created. So 2, 3, 4, -5, you can see that here, and then -1, -1. Then after I sort them using the arrays.sort, you can see they come out in a different order. Okay, so I got -1, -1. which is going to be the closest to the origin, and then negative 2, 1, the next closest to the origin, and then they're going to get continually farther away from the origin the further I go out, so that 4, negative 5 is the farthest point away from the origin. Okay, so that's our current implementation. What we need to do is we need to change it. What we want to do is we're going to just go ahead and we're going to comment out this code right here. Okay. And instead, what we're going to do is we're going to write our own implementation right here. So this is what's going to be done by the student. That's us today. What we're going to do is we're going to go by the quadrant. Well, fortunately, we already have a quadrant number. So let's do this. Let's do our quadrant is going to equal to this dot quadrant. And then the other quadrant, and let me shorten it just to Q. The other quadrant is going to equal to other dot quadrant. Now, if they are in the same quadrant, I need to go by the distance to origin. So let's just say if our quadrant is equal to other quadrant, then I need to use the distance to origin. The distance to origin, as we found, was right up here, right? So let me just copy that line right there. And if our quadrants are the same, I'm just going to return the distance to the origin. Otherwise, I'm going to use our quadrant number. Well, as we know, we can just return our quadrant number minus the other quadrant number. And that will give us the math that we needed to do. So this is doing the simple math. This is the same as if I were to go if our quadrant number is less than other quadrant number, then I'm going to return a negative 1, something like that, right? But we're just going to use a shorthand notation this way. So shorthand implementation. Let's see if I run this guy. I got an error. Let's see, what is my error here? Oh my goodness. Interface or enum expected other class. Okay, that is on right here. Public int compare to sortable other. Public int compare sortable. Oh, I forgot to comment that line. That is important. Okay, that was it. I just forgot to comment that out. Let's run this guy, and when I run it again, you'll see that I got my original location, and the first thing it's going to do is if it's on the origin, it puts those first. So I'm not on the axes, okay? If it's because that'll be in the 0 quadrant, and I'm going to sort by quadrant. If you're on the 0 quadrant, right here, okay, if you're on the axes, you're on the 0 quadrant, you're clearly going to be first. Now these two are both on the axes, but this one is closer to the origin, so it sorts that one first. Then I go to 2, 3, which would be up here in quadrant 1. Then it's negative 2 and 1, which is quadrant 2. And then as I continue down the way, I get negative 1 and negative 1, which is quadrant 3. And lastly, I get 4 and negative 5, which is quadrant 4. And that's exactly how I wanted to sort. It was first by quadrant. If the quadrants are equal, then it's distance to the origin. Whew. Very, very cool. I got that done. Now I'm going to show you slightly different ways. This is more advanced syntax ways for implementing the same thing that I've done here before. I'm going to put this back as if that still exists, okay? Then what I'm going to do is I'm going to make this a different method. I'm going to call this, right, I'm going to call this my comparable, and it's going to take two sortable points. It's going to take A, and then I'm going to do B, okay? A and B, and so I still want to do sort of the same thing. So I'm going to say that the AQ is going to equal to A quadrant. The BQ is going to equal to the B quadrant. Now if AQ is equal to the BQ, then what I'm going to do is instead of doing this whole line again, I'm just going to ask, hey A, I want you to compare yourself to B. Compare to B. And that does just by the distance to the origin. Now you're saying, oh wait a minute, this is my comparable. Oh wait, and then I forgot. we have to do AQ minus BQ. How do I get this method to be called instead of this one when I do my sort? Because right now, this one's going to run. So if I were to run this guy, hopefully it compiles, then what I see is that it still sorts by distance to origin, okay? It's still calling this method here. It did not at all call mine. But there's a really neat way that I can go up into here, and in my sort, I can say, you know what? I don't want you to use the comparable interface. Okay, I want you to use the sortable point method that I just wrote called my comparable. Okay, use this as my comparable. That is saying, go to this class, use my comparable. So when I run this guy, of course, I get an error. It says, suitable method cannot be found for sortable point my comparable. And it's because I didn't make it static. So let's make it static. Now, compile first, please. Okay, that runs. And here's the latest output. So again, those on the axes return first, and I get the one closest to the origin. So we actually called this one first. How cool is that? There is yet more ways that I can do this. If I got so lazy that I didn't want to write that method down there, let's just do this. Let's sort. If I wanted to sort by just the x, whatever x value, I'm going to ignore y. That's the only way I want to sort. Okay, I'm going to write I'm going to copy this method here. Okay, and I'm going to do my comparable. I'm going to just say x. Okay, and all I'm going to do is just look at the x value. So I'm going to say I'm going to return a dot get x minus b dot get x. So I'm just going to sort only by that. So if I come up here, I can do comparable x right there. And if I run this guy, I get an error. It says possible lossy conversion. Oh, right, because this is double values. So I need to do this. I need to grab my math signum. Okay, I'm just going to put that right in there. And I'm going to put another parameter, another parenthesis over there, compile it. Does this run now? Does it compile? Yes, it does run. And now what we'll see is that -2 of the x comes first, then -1, then 0, then 2, then 4, and then 4 again. So these were identical. So which one you get is probably just completely random order. I didn't do anything in here whatsoever to do sort of any tiebreaker. So now I'm passing in the comparable up here, and I passed in a new one. Let's say that I'm too lazy to write that whole method. That really, because it's just this one line. It's just that one line. Can't I just return that one line? Isn't there something easier? And yes, there is. There's something called a lambda expression. Oh, you're going to get confused by this one. Let's say I had a method that took two parameters, a and b, and I wanted to return the integer of math sum a get x minus b get x. What the heck did you just do, Mr. Stride? Let's do a really quick, like lightning lesson on lambdas. Lambdas is just a very short way to create a method. And since the method has a name over here, but a lambda expression has no name, we call it anonymous, okay? So it's super slick way. What we have is a compare to method over here, public int compare to. It takes two parameters and it does something with the values in here. Over here we've done the exact same thing, only we've done it with an anonymous method and using this dash greater than sign or this arrow, right? It's two characters to make it a lambda expression. So what you see on the left and what you see on the right are identical. This right here, this is called a lambda expression. And it is a method. It's a shorthand notation to create a method. maybe do I have the right number of parentheses? My compiler will let me know. Let me compile this guy. And nope, I need another printout here. Can't quite do it in my head. This will do exactly what I did before. It creates a method right here. The A and the B are the arguments that get passed into this method. This here says I'm doing a lambda expression that is a method, and then I'm going to return it right here. So if I run this guy, I will get the same values that I had before. So it sorts by the x value. That is wild and crazy stuff. So this is using a lambda expression. If I take all that out, it's going to sort according to the compare2 method, which is right here. And if I want to pass in a certain method, I can create a new one, or I can do a lambda expression, all sorts of different ways to do some sorting in here. I know that was a lot, pretty fast. What do you need to know for the AP exam? Virtually none of this. All you need to know is that there is something called an array sort, and even that you probably won't need to know on the AP exam this year. This is all just cool stuff using interfaces, which you don't need to know either, and I hope you enjoyed it.